Welcome to an exhilarating exploration of the grand cosmic ballet that unfolds across the universe. The universe is a vast and dynamic stage where galaxies, the colossal islands of stars, engage in a continuous, intricate dance. This cosmic choreography is more than just visual splendor. It is a profound process that shapes the very fabric of the cosmos. Join us as we delve into the fascinating world of galaxy interactions, where collisions, mergers, and tidal forces sculpt the universe in ways that influence galactic evolution on the grandest scales. Our universe is not a static expanse of isolated entities, but a dynamic and interconnected network. Galaxies are woven into a grand cosmic web, a sprawling lattice of dark matter and gas that connects clusters and groups of galaxies. Within this web, galaxies are drawn together by their mutual gravitational attraction, leading to a rich tapestry of interactions. These interactions are pivotal in shaping the structure and evolution of galaxies across cosmic timescales. One of the most dramatic phenomena in this cosmic dance is the collision of galaxies. As two galaxies approach each other, their gravitational fields begin to interact, creating a complex gravitational tug-of-war. This interaction initiates a series of events that unfold over millions or even billions of years. The process is gradual and intricate, with the galaxies' mutual gravitational forces causing profound changes in their structures. As these colossal galactic bodies draw near, their shapes become increasingly distorted due to tidal forces. The gravitational pull from each galaxy stretches and warps the other, leading to the formation of striking tidal tails, long stream-like structures of stars and gas that bridge the two galaxies. These tidal features not only highlight the intense gravitational forces at play, but also reveal the intricate details of the interaction process. During a galactic collision, the dense clouds of gas and dust within each galaxy collide and intermingle, setting the stage for intense star formation. This process, known as a starburst, results in a rapid and prolific creation of new stars. The collision compresses the interstellar gas, triggering the formation of massive star clusters and superheated stellar nurseries. These newborn stars shine brightly, contributing to the visual spectacle of the galactic interaction. This burst of star formation also has significant implications for the galaxies involved. The high rate of new star births enriches the interstellar medium with heavier elements, which are crucial for the formation of planets and life as we know it. The chemical composition of the galaxy evolves, influencing the creation of subsequent generations of stars and shaping the galaxy's future. When two galaxies collide and merge, the resulting structure can be vastly different from the originals. The merging process often transforms spiral galaxies into elliptical ones. Spirals, characterized by their organized disks and spiral arms, lose their intricate structure as they coalesce into a more rounded, less organized elliptical galaxy. This transformation reflects the fundamental changes that occur during galactic mergers. The merger of galaxies results in the formation of a massive central bulge. a dense core of stars that becomes more prominent in the new galaxy. The gravitational forces of the combined galactic mass concentrate the stellar population, altering the overall morphology of the galaxy and affecting its future evolutionary path. At the heart of many galaxies lie supermassive black holes, and during a galactic collision, these central black holes are not exempt from interaction. As the galaxies merge, their central black holes may eventually come together, initiating a dramatic and energetic event. The merging of supermassive black holes releases colossal amounts of energy in the form of gravitational waves, ripples in space-time, that were first predicted by Einstein's theory of general relativity. These gravitational waves carry valuable information about the black hole merger and provide a unique window into the most extreme and energetic processes in the universe. Observatories like LIGO and Virgo are designed to detect these ripples, offering insights into the dynamics of black hole mergers and enhancing our understanding of the fundamental nature of space-time. The tidal forces exerted during galaxy interactions create a variety of striking and informative features. Tidal tails, bridges, and plumes of stars and gas form as the gravitational pull between galaxies distorts their shapes. These features are not merely visual anomalies. They provide critical clues about the gravitational dynamics and interaction history of the galaxies. Studying these tidal features helps astronomers reconstruct the interaction history of galaxies and understand the physical processes driving their evolution. By analyzing the structure and distribution of these features, scientists can gain insights into how galaxies interact, merge, and evolve over time. Observing and understanding these complex interactions require advanced observational tools and sophisticated computational models. Space telescopes like the Hubble Space Telescope and the James Webb Space Telescope provide detailed images of interacting galaxies, revealing their intricate structures and star-forming regions. In addition to observational data, computer simulations play a crucial role in studying galaxy interactions. By modeling the gravitational forces, physical processes, and evolutionary trajectories of interacting galaxies, scientists can simulate galactic collisions and mergers, gaining a deeper understanding of the dynamics at play. The study of galaxy interactions is fundamental to understanding the larger-scale structure and evolution of the universe. These cosmic events influence the formation of galaxy clusters, the distribution of cosmic matter, and the growth of supermassive black holes. They also offer a natural laboratory for studying key astrophysical processes and the role of dark matter. By observing and modeling galaxy mergers and collisions, scientists can refine our understanding of the universe's history and evolution. These interactions provide valuable insights into the growth of galaxies, the formation of stars, and the dynamics of dark matter, enhancing our comprehension of the cosmos. As we look up at the night sky, we witness the grand cosmic dance of galaxies, each interaction and merger shaping the universe in profound ways. The dynamic processes driving galaxy evolution remind us of the beauty and complexity of the cosmos. Thank you for joining us on this captivating journey through the dynamics of galaxy interactions. As we continue to explore the universe, let us be inspired by the intricate dance of galaxies and the endless wonders that await discovery. Stay curious, keep exploring, and let the cosmic dance of galaxies ignite your imagination and sense of wonder.